Dear children, today we are going to continue the remaining portion of the chapter Ray Optics. There the last content is Optical Instruments. Optical instruments consist of simple microscope, compound microscope, astronomical telescope, etc. There we first want to study the simple microscope. A simple microscope means it is just a magnifying glass. It is just it is a convex lens of short focal length held close to the eye. That is the simple microscope. There we are considering two image visions. Number one, when the image is formed at the least distance of distinct vision, what is the magnification power? Secondly, when the image is at the infinity, when the image is formed at the infinity, then what is the magnifying power? These are the two cases of image formation in simple microscope. So, in the simple microscope, we are just a simple convex lens. So, when the object is placed between the focus and the optic center of the convex lens, we get a virtual, erect and magnified image on the same side of the lens. Okay, so that we can draw in the figure. So here we can take the focus F, and this is the optic center. Then here this side also focus is there. Then when the object is placed in between focus and optic center, we can place the object here. Then what is the rays? What are the rays? So one ray passes through the optic center. Okay, one ray passes through the optic center. And another one ray passes parallel to the principal axis. Then after refraction, it passes through the focus. Okay. And these two rays meet on the same side of the lens. There we get an erect and magnified image on the same side of the lens. This is the erect and magnified image. Clear? So here we can take, this is the object AB and this is the image A dash B dash. Okay, so that is the image formation. Then we can see the image here, isn't it? We can see the image here. So here what is the magnification, or how will you find out the magnification? So magnification or magnifying power of a simple microscope is defined as the ratio of, okay, we can write here magnifying power. It is defined as the ratio of angle subtended by the image at the least distance of distinct vision to the angle subtended by the object at the least distance of distinct vision. Okay, so we can write here, it is the angle subtended, okay, angle subtended by the image at the least distance of distinct vision to the angle subtended least distance of distinct vision. Clear? Divided by angle subtended by the object at the least distance of distinct vision. So this is the magnifying power. This is the formula to calculate the magnifying power at the least distance of distinct division. Okay. So this is the formula for calculating the magnifying power. So in the figure, what is the angle subtended by the image? So this is the image. So this is the angle subtended by the image with the eye. Okay. This is the angle subtended by the image with the eye. So the image is formed at the least distance of distinct division. So we can note here that is the beta. And this is the object distance u. Clear? And the image is formed at the least distance of distinct division, that is the 25 centimeter. So this is the angle subtended by the image at the least distance of distinct division. So we can write that is the beta. So we can write m equal to beta divided by, then what is the angle subtended by the object at the least distance of distinct division. So here this is the object. So the angle subtended by the object and angle subtended by the image is same. It appears to be the same. So here we can write the angle subtended by the object as alpha. So from the figure, beta and alpha appear to be the same. So we can draw separately the angle subtended by the object. Okay. So this is the object and the object is at the least distance of distinct division from the eye, and this is the angle alpha. Clear? So the object is at a distance of least distance of distinct division from the eye. So the angle subtended with the object is alpha. So we can write here m equal to beta by alpha. Okay. Angle subtended by the image at the least distance of distinct division and the angle subtended by the object at the least distance of distinct division. Why we separately draw the object with the angle separately here? Because angle subtended by the object and angle subtended by the image are same. So here angle subtended by the image, let it be beta, and angle subtended by the object, let it be alpha. So this angle, this alpha is the particular angle for the least distance of distinct division when the object is, okay, that is alpha is the particular angle when the object is at a least distance of distinct division from the eye. Clear? So we can write m equal to beta by alpha. So for small angles, what is the small angles? Beta tends to be tan beta and alpha tends to be tan alpha. So from the figure, what is the tan beta? Tan beta equal to AB divided by OB. Okay, tan beta equal to AB divided by OB. Then what is tan alpha from the figure? That is AB divided by, so this is the optic center. Okay, AB divided by, that is the least distance of distinct division. We can write D. Okay, so AB divided by D. Clear? AB divided by D. Then we can cancel this AB and AB. So what is the answer here? That is m equal to D divided by OB. So that is D divided by, what is the OB from the figure? That is the object distance. Clear? So m equal to D by U. So this is the magnification in terms of D and U. Okay. Then you want to find out the magnification when the object is at the least distance of distinct division and image is also at the least distance of distinct division. So this figure represents the simple microscope when the image is formed at the least distance of distinct division. So what is the magnification if the angle, okay, if the angle, if the image is formed at the least distance of distinct division, that is the minimum distance that we can see. So if the image is at the least distance or distinct division, we can write V equal to image distance V equal to minus D. So you want to put the sign also, okay, for the object distance and for the image distance you want to put the sign. So here the image is formed at a distance of D, so we can write V equal to minus D. So from the thin lens formula we can write, what is the thin lens formula? That is 1 by V minus 1 by U equal to 1 by F. So that is 1 divided by minus D minus, so what is the object distance in terms of the sign? That is minus U, that is equal to 1 by F. So from again we can write 1 by U equal to 1 by F plus 1 by D. Clear? So this is the, so this value you put it in the equation of magnification M equal to D by U. Okay, that is 1 by U equal to 1 by F plus 1 by D. So we can write magnification M equal to D into 1 by U. That is M equal to D into 1 by F plus 1 by D. So that is magnification M equal to 1 plus, okay, that is D into 1 by D, that is 1 plus D by F. So this is the magnification of a simple microscope when the image is at the least distance of distinct division, and the diagram for the simple microscope when the image is at the least distance of distinct division, you want to draw this one. Clear? So this is the case of when the image is formed at the least distance of distinct division. You should remember the angles, that is the angle with the object and eye, and angle with the image and the eye. Then what is the magnifying power? It is the angle subtended by the image at the least distance or distinct division to the angle subtended by the object at the least distance of distinct division. So what is the magnification of the simple microscope when the image is at the least distance or distinct division? That is M equal to 1 plus D by F. Clear? Now the second case is image is formed at infinity and the object is at least distance of distinct division. In the first case we studied that image and the object is at the least distance of distinct division. So here the image is formed at infinity and the object is at the least distance of distinct division. So for getting the image at infinity, we should place the object at focus. Okay, so we should place the object at a focus here. Then in the first, like in the first figure, this is the optic center and the one ray passes through the optic center like this, and another one ray after refraction it passes through the focus. Then these two rays doesn't meet and the image is formed at infinity. Okay, image at infinite position. So this is the figure representing image is formed at infinity. So this is the angle subtended by the image with the eye, and the object is at the least distance or distinct division, and we should draw the object angle separately like in the first figure. So here you want to find out the magnification. So the object is at F. So the object distance is this one, that is equal to F. So what is the general formula for the magnification? That is we already derived in the first case, that is M equal to D by U. Clear? So here the object is at F. Okay, U is placed at F. So we can write M equal to D by F. Clear? M equal to D by F. So this is the magnification for the image formed at infinity and the object is at the least distance of distinct division. and this is more comfortable vision. Okay, when the image is formed at infinity, this is the most comfortable vision. Clear? Compound microscope. It is an optical device used to see magnified images of tiny objects. So, a good quality compound microscope can produce magnification of the order of 1000. And this compound microscope consists of two convex lenses. One is the objective. It has very short focal length and small aperture, and it is placed near the object. Second one, eyepiece. It has large focal length and large aperture and placed near the image. So we can draw the diagram of the compound microscope. First we can draw the objective, and it is of very short focal length. Okay, so this is the objective. It has very short focal length and very small aperture. Then you place the object beyond the focus of this objective. Focus of the objective is noted as F4 dash. So you should place the object beyond the focus of the objective. And then, like in the first case, a ray of light passes through the optic center. Then another ray passes parallel to the principal axis, and after refraction passes through the focus. Okay, passes through the focus of the objective. These two rays meet here, where we get the image A dash, B dash. The object is AB. Clear? Then this image acts as a object for the eyepiece. Eyepiece has large aperture. Okay, eyepiece has large aperture and large focal length. So this image acts as a object for the eyepiece. So we should place this in between the focus of the eyepiece and the optic center. Clear? Then again, from here also one ray passes through the optic center. So you want to draw the rays, arrow mark. Okay, passes through the optic center. Then another one ray, after refraction, it passes through the focus of this eyepiece. Then these two rays meet and we get image. Okay, these two rays meet and we get an enlarged image A dash, B double dash. Clear? This is the diagram of the compound microscope. Once again, here it consists of, compound microscope consists of an objective of small aperture and small focal length, and a eyepiece of large aperture and large focal length. We should place the object beyond the focus of the objective, and then the image is formed beyond the focus. Okay, that image acts as a object for the eyepiece. So that is in between the optic center and the focus of the eyepiece. Then after the refraction, a final image is formed at the least distance of distinct vision from the eye. Okay, least distance of distinct vision from the eye. So we can see the image here. Clear? So we can see the image in this portion. So this is the ray diagram. So this is the case of final image is formed at the least distance of distinct vision. Okay, compound microscope for the compound microscope. First case is the final image is formed at the least distance of distinct division, that is the D. So this is the figure or diagram representing that one. So you want to find out the magnification of this compound microscope when the final image is formed at the least distance or distinct division and the object is at the least distance of distinct division. So what is the angle subtended by the image and the eye? So this is the angle. Okay, this is the beta. This is the angle subtended by the image with the eye. So this is the angle beta. So what is the magnification of the compound microscope? We can write it is the total magnification of the objective and the eyepiece. Clear? So here the eyepiece acts as a simple microscope. So magnification of the compound microscope is the combination of or the product of magnification of objective and magnification of the eyepiece. So from the figure, what is the magnification of the objective? We can write it is the image distance of the objective by object distance. So what is the object distance here? This is the object distance for the objective U0 and this is the image distance for the objective. Clear? And this is the object distance for the eyepiece, isn't it? And this is the image distance for the eyepiece. Clear? So we can write MO, that is magnification of the objective equal to V0 by U0. And what is the magnification of the eyepiece? Eyepiece acts as a simple microscope. So what is the general formula for the magnification of the simple microscope? That is the D by U. So here it is the eyepiece. So we can write. So here that is the V0 by U0. Okay, magnification of the objective V0 by U0. And what is the magnification of the eyepiece? D by UE. Okay, general formula for the simple microscope, magnification of the simple microscope is D by UE. So here it is the symbol, that means eyepiece acts as a simple microscope. So we can write D by UE. Then for the least distance of distinct division. So we are taking the case for the least distance of distinct division. Clear? Least distance of distinct division. That is the case. Least distance of distinct division. What is the image distance? VE. That is image distance for the eyepiece. VE equal to minus D. Clear? So from the lens formula we can write, okay, that we derived in the simple microscope in the first case. Okay, that is 1 by FE. You just go through that. That means that simple microscope 1 by FE equal to 1 by VE minus 1 by UE from the thin lens formula. So what is the VE? That is minus D minus UE. We can also substitute the sign. Okay, minus that is minus 1 by minus UE. Okay, so that is equal to 1 by FE equal to 1 by UE plus 1 by D. Okay, that is 1 by UE minus 1 by D. Okay, that is minus 1 by D. Clear? So from this we can write 1 by UE equal to 1 by FE plus 1 by D. Then we can substitute this 1 by UE in the formula M equal to V0 by U0 into D by UE. Okay, so we can write magnification M equal to V0 by U0 into D into what is 1 by UE? That is 1 by FE plus 1 by D. So that is equal to V0 by U0 into D into 1 by D. That is a 1. 1 plus D by FE. So this is the magnification of the compound microscope when the final image is at the least distance of distinct division and object is also at the least distance of distinct division. Clear? So we derived the formula M equal to V0 by U0 into 1 plus D by FE. Clear? Suppose if the object is placed close to the focus. Okay, if the object AB is placed close to the focus, then U0 is equal to what? Minus F0. Clear? U0 equal to minus F0. So we can write here U0 equal to minus F0. Then what happens to the image here? Also the image A dash B dash is also close to this eyepiece. This image A dash B dash is also close to the eyepiece. When the object is close to the focus, then image A dash B dash is also close to the eyepiece. Then what is the V0 here? V0 is equal to the length of this microscope or the distance between the two lenses. Okay, so we can take the distance between the two lenses as capital L. So we can write here V0 equal to, in that case we can write V0 equal to L. So we can substitute the magnification formula. So that is M equal to V0. Okay, V0 is what? V0 equal to L divided by U0 equal to minus F0 into 1 plus D by Fe. Clear? So this is the magnification when the object is very close to the focus and the image is also very near to the eyepiece. In that case, U0 equal to minus F0 and V0 is equal to the length of the microscope or the distance between the two lenses. So this is the magnification when the final image is at the least distance of distinct division. Clear? Second case of the compound microscope, image is formed at infinity. So here you want to change a small change in the first figure. So in the first figure, the image formed by the objective is in between the focus and the optic center of the eyepiece. Then here you want to form the image at the focus of the eyepiece. Then only we can get the final image at infinity. Okay. So here we can draw the eyepiece. It has a small aperture and short focal length. Then here similarly in the first case, the object is placed beyond the focus. Then a ray passes through the optic center and another one ray passes parallel to the principal axis, and after refraction it passes through the focus where we get the image. That is here the object AB and here the object A dash B dash. And this image is formed at the focus of the eyepiece. Okay. Then here we can draw the eyepiece. Then this image acts as an object for the eyepiece. Then from here also a ray passes through the optic center and another one ray passes through the parallel to the focus and parallel to the principal axis, and after refraction passes through the focus. Then you can draw the arrow mark like this. Okay. So here this is the focus. And this image do not meet because here the image formed by the objective act as an object for the eyepiece and it is at the focus of the eyepiece. Okay, so when the object is at the focus, final image is formed at the infinity. Clear? And this is the object distance for the objective, that is U0, and this is the image distance for the objective, and this is the object distance for the eyepiece, that is equal to Fe. Okay, then we can write the magnification. So what is the magnification? So here magnification is the product of magnification of the objective and eyepiece. So what is the magnification of the objective? That is V0 by U0. And here the eyepiece acts as a simple microscope. So what is the magnification for the simple microscope? In the case of normal adjustment position or infinity, here we can say that it is the normal adjustment position. That is D by F. Here it is the eyepiece. So we can write D by Fe. Clear? So this is the, so we can once again we can write that is M equal to V0 by U0 into D by Fe. So this is the magnification for the simple microscope and the image is formed at infinity, or we can say that it is the normal adjustment position. Then when the object is very close to the objective and the image is formed very near to the eyepiece, then how can we change the formula? That is M equal to L by F0 into D by Fe. Okay, so this is the magnification. L is the distance between the length of the two microscopes. Clear? By applying the sign convention, U0 equal to minus F0, so we can put the minus sign here. So once again, magnification for the compound microscope and the image is at the least distance or distinct division is M equal to L by minus F0 into 1 plus D by Fe, and when the image is at infinity, then M equal to L by minus F0 into D by Fe. Clear?